So hi there folks, we're now in our next video in our playlist and the fundamentals of mathematics, and here we're going to continue what we have started in the last video, that is in the ratio and proportion. And today we're going to talk about proportion this time. We've talked about ratio in the last video. Now proportion is actually, a proportion is just the equality of two ratios. So it's simply the equality of two ratios. So put two ratios in I mean, put an equal sign between two ratios, that's already a proportion. So if we have A is to B equals C is to D, then this statement is what we call a proportion. Okay, so therefore this statement is called a proportion. And let's talk about the parts of a proportion. The end parts of it. Okay, what I mean is the A here and the D here, we call them the extremes. Okay, the extremes. And the inside parts of a proportion, what I mean is the B here and the C here, that's what we call the means. Okay, so the B and the C. So these are the means. Um, we have one specific law for or in doing or solving problems involving or ratio and proportion, of course. So we call this a law of proportion. So it's very simply stated here. So it is said that in any proportion whatsoever, the product of the means, product, so you multiply them, the product of the means equals the product of the extremes. So again, in any proportion, for all proportions that you can see, the product of the means equals the product of the extreme. So they must be equal. So going back to the definition of a proportion. So we have A is to B is equal to B is to D. Therefore, if this is true, then A times D, okay, A times D, AD, is equal to B times C. So this AD is our extremes. This B and C is our means. Okay, or our means rather. So let's try to see for these two examples for numbers 1 and 2, and tell if they are a proportion or not. So let's try to first answer number 1. So again, the product of the means equals the product of the extreme. So let's try if this is true. So to answer this, we write it in this way. So 2 times 6, that's our extremes. 2 times 6, okay, is equal to 3 times 4. 3 times 4. Okay, so continuing in this manner, we have 2 times 6. What is 2 times 6? 2 times 6 is 12. 2 times 6 is 12. And just a moment. Um, so this is 12 again. And 3 times 4 is also 12. So therefore, this here, 2 is to 3 equals 4 is to 6, since we ended up in an identity. So therefore, this is indeed a proportion. So, so we say 2 is to 3 equals 4 is to 6 is a proportion. Is a proportion. Okay. How about number 2? So we have 3 is to 5 equals 2 is to 5. So let's do the law, product of the means, or product of the extremes rather, times the product of the means. So it should be equal. So for number 2, put a line here so that you won't get confused. For number 2, so 3 times 5 is said to be equal to 5 times 2. I think in this part you can see that the answer already, it's clear as day. So 3 times 5 is 15, okay? And 5 times 2 is equal to 10. So they are not equal 15 is, of course, not equal to 10. So we can say, therefore, that 3 is to 5, 3 is to 5 equals 2 is to 5 is not a proportion. Is not a proportion. Proportion. Or we can simply say that this is unequal. Okay, so this proportion is not equal. So if we're going to put this in a fraction bar, so imagine 3 over 5 equals 2 over 5, so they are not equal, so therefore we can put an unequal symbol here. We can cross the equal sign indicating that they are not equal. Or simply we can imagine this in simple division. So 3 divided by 5 is not equal to 2 divided by 5. It's very clear because they have the same denominators. So they are never equal. They're never equal. Okay, that cannot be. Okay, let's proceed to the third example, shall we? So in our third example, we now have a statement. In solving proportion, where there is an unknown item, we will define or we will let this unknown item into a variable. So if there's a variable there, we use the law of proportion. So for instance, so we have here x is to 4 equals 12 is to 16. So there's a variable here, so that is an unknown item. So it is for us to identify what that item is. What's the meaning of that item in this kind of proportion? Okay, provided that this we say that this is a proportion. Okay, so let's answer this here. So law of product, or law of proportion rather, the product of the extremes is equal to the product of the means. Okay, so what we have is, so 16 times x is 16x, 16x equals 4 times 12. So let's not multiply that yet. We continue. So we have 16x, we cannot do anything about it actually. Just let it be. 4 times 12, what is 4 times 12? So that's going to be 48, right? 48. And then what we do is to, by algebra, we will isolate the x. So that is, we're going to transpose the 16 to the other side. We do that by the opposite operation of multiplication. That is, the opposite operation of multiplication is, of course, we know that as division. So we're going to apply division over here. So that is, we're going to divide the whole equation by 16. Okay, by 16. Divide is by 16. Divide is also by 16. Which will in turn give us what number? So this 16 will be cancelled up. And we're going to divide this. How many 16s are there in 48? So if we can cancel this, this becomes 1. We can also cancel this. This becomes 3 actually. So there are uh, 3 16s in 48. So you can use the multiplication table for 16 to know that. So we now have 16, 32, and then 48. And then I think we can arrive to our answer. Um, x, therefore we can say that x is equal to 3. So since x is equal to 3, in order to complete the proportion, this must be substituted into 3. That is, this is going to be 3 is to 4 equals 12 is to 16. Okay, so that's a proportion. Okay, that is a proportion. Let's proceed to the next example. This is going to be in the form of a word problem. Mm, let's move it more. So we have it here. Let me read it once. So number 4. A car travels 300 miles for 15 gallons of gasoline. So meaning for a tank that holds 15 gallons of gasoline, okay, or in that moment, this car holds 15 gallons of gasoline. It can travel to up to 300 miles. Or let's just say this is constant. This car can travel 300 miles with 15 gallons in it. on it rather. How many gallons? We are asked how many gallons. Okay, how many gallons of gasoline will be consumed on a trip covering 800 miles? So imagine a trip that will consume us 800 miles. How many gallons do we need in order for us to arrive there in 800 miles? Or we can say that um, how much do I need to budget? Okay, my travel in which how many stops, I can know I can I can budget my trip. Okay, since I know that there are 800 miles of traveling, so how much gallon do I need to budget for that? So let's set this up for a proportion as a proportion. So we know how do we set this up? Let's write the solution. We know that there are this car here particularly can run for 300 miles for 15 gallons. Okay, so we say that this is the miles. The unit here is miles. This is for the gallons of gasoline. Now what we will do is to set up its proportion. Okay, since we're traveling with the same car and we want to assume that even though it's not given. So we are traveling using the same car. The question is how many gallons? So we don't know the gallons, how many gallons do we need, but we know that we will be covering 800 miles. So since miles here is the first in our ratio in this left-hand side, so we need to follow that order. So this must be miles here, and this must be gallons here. Okay, so this since we will run for 800 miles, how many gallons do we need? So this is a question mark. Or better yet, let's denote this as x. Let's denote that as x. Okay. Um, let's do then the proportion since we have here a proportion already. So this is we have means, we have extremes, we have two ratios and an equal sign between them. So we can apply the law of proportion then. That is the product of the means is equal to the product of the extremes. So let's do first the extremes and then the means. So we have uh, 300x equals 15 times 800. Okay, let's have some space here. I think I can still fit. Okay, so 300x, we cannot do anything about that for now. So let's just write it 300x. Now what is 15 times 800? So let's try to solve that. 5 times 15. Okay, we just need to put two zeros here, right? So 8, 9, 0, 9,000. Am I right with that? 9,000. So 9,000. Um, so we'll have 8. 8 times 1 is 8. 8. 4 times 5 is going to be, so this is going to become 8. 8 times 5 is 40. Let's carry this over. And what we'll have is 12 rather, sorry. 12 thousand. 12,000 is the answer here. Okay, so it's 12,000. So let's proceed. I have no more space down below. Um, 300x, let's write it here. 300x equals 12,000. Now we want to isolate the x here, so that is we're going to divide the whole equation by 300. So dividing this whole equation by 300, let's just illustrate it over here. So we'll divide this by 300. Just a moment. 300 here, and we'll also divide this by 300 here. So what do we have? What we have here is this is going to be x is equal to 12,000 over 300. So 12,000 over 300, we can just cancel the zeros here. So we have 1 0 left. 12 divided by 3 is 4, and copy the 1 0 which is left here. So meaning our answer for x is 40. So we go back to the question. A car travels 300 miles for 15 gallons of gasoline. How many gallons of gasoline will be consumed on a trip covering 800 miles? So the answer is 40. So in order for us to cover 800 miles of travel, we need 40 gallons of gasoline. Okay, so I hope I made it clear in the lesson of proportion. I'll be creating more videos um, depicting the examples of proportions. Okay, so don't worry. So that's it. Thank you very much for watching. I hope you learned something from here. And yeah, I will. I think I'll see you soon. Don't forget to hit the like button and of course subscribe. Okay, thank you.